Good afternoon, respected faculties and my dear friends. My name is Rudra Bhatt, Department Information Technology in Silver Oak University, Division A3. Today I will be explaining what is circular queue. Understanding the basic what is a queue. Imagine a line at a ticket counter. The first person to join the line is the first one to get served. This first in first out FIFO principle is exactly how a queue works in computer science or IT information technology. New elements are added at the rear and the elements are removed from the front. The problem with regular queue space waste. In a traditional linear queue, when elements are removed from the front, the, the empty space created cannot be reused. This leads to inefficient memory usage as the queue quickly fill up even if elements are continuously dequeued, leaving unused dead space at the beginning of the array. Enter the circular queue. Efficiency first. A circular queue reuse empty space by connecting the last element to the first, forming a logical circle. This eliminates the problem of wasted memory, making it highly efficient for managing data streams. Continuous flow. Data can be added and removed continuously as if the queue never truly fill up, as long as there is at least one empty slot. This ensures a seamless flow of operations without frequent memory reallocation. How it works? The round way of storing data. A circular queue uses a fixed size array, but instead of linear movement, the front and rear pointer wrap around. When the rear pointer reaches the end of the array, it cycles back to the beginning, treating the array as if it were at a circle. This clever trick maximizes storage utilization. Adding data, the enqueue operation. First, check for space. Before adding the queue, check if there an empty slot. If the queue is full, the operation fails, preventing data overflow. Second, increment rear. The rear pointer moves to the next available position. If it reaches the end of the array, it wraps around to the beginning. Third, insert element. The new data element is then placed at the position indicated by the rear pointer. Removing data, the dequeue operation. First, check if empty. First, the queue verifies if there are any elements to remove. If the queue is empty, the operation fails gracefully. Second, retrieve element. The element at the front pointer current position is retrieved, which is the oldest element in the queue. Third, increment front. The front pointer then moves to the next position, like the rear is also wraps around to the array start if it hits the end. Why use it? Benefits of circular queue. Memory optimization. Elements wasted space by reusing dequeued slots, making it ideal for a system with limited memory. Enhanced performance. Reduce the need for frequent data shifts, leading to faster NQ and DQ operation compared to linear queues. Constant time operations. Both adding and removing element take 0 or 1 time, ensuring predictable performance regardless of queue size. Circular queue. Everyday example. From print spoiling to CPU scheduling and even managing traffic light systems, circular queue are slightly powering many of the technologies we use daily. They are also integral in streaming media players for managing audio and video buffer, ensuring smooth playback. Key takeaways of circular queue: efficient space utilization. Circular queues prevent memory waste by reusing the slots, making them perfect for resource constrained environment. FIFO principle in loop. They maintain the FIFO, first in, first out, but with added benefit of a wrap-around structure for continuous operation. Fundamental for system design. Understanding circular queues is key for optimizing buffer management, task scheduling, and more in computer science. Thank you so much for your time and attention. I hope this presentation made the concept clear and useful. Thank you.